Yeah, g'day heathers and gentlemen. Welcome back to this old lathe channel where I've been working on modernising this beautiful old Schaublin 125 CNC lathe. I've still got a fair bit of configuration work to do in LinuxCNC, but I need to make this part. Okay, so the part I need to make is this. It's an M14 thread. It's got this feature that I need to trepan in from one end. And I could knurl it, although that's not really that critical. This is the developing tank which I made for developing a whole roll of 16mm movie film. Screws in here, like that. Forms part of the light trap. And while you're developing the film, you twist the whole spool with this to keep the chemicals agitated. But unfortunately, that means it's the most highly stressed part of the whole thing. 3D printed, it just wasn't strong enough. This is 50mm diameter PVC bar, so that's what I'll be turning my part out of. Looks like I need 80mm cut off. Right, I know what I need to make. I've got the raw material prepared, but how does the lathe look? Although last week I got the lathe wired up, I didn't actually get it tested. Now you might remember I had to make up this right angle connector, which meant I switched the two encoder cables and then also switched all of the other cables to match. I've got the X encoder and motor control on a drive that was programmed with the parameters of the Z. So the inertia ratio is definitely wrong. So I need to reprogram X to the Z and Z to the X. Now to do that programming, I've been using this USB to RS-232 cable, but then a RS-232 to micro USB adapter I wired up. But I can't for the life of me find it. I mean, I even cleaned up the workshop bench to try and look for it. Oh well, plan B, I'll just physically swap the two drives over. Okay, so that's that done. Right, let's crank up LinuxCNC and see what still works, shall we? Well, that's a good sign. It didn't fail out straight away. That surprises me. Okay, I can activate the machine. How about jogging? Okay, that seems to work fine. Okay, jog right, moved left, joint following error. That's going to be something related to the commanding of direction versus the encoder. I need to look into that. So I need to sort out the Z encoder. Or maybe it's just the direction of movement. I'm glad the MotoGP season's running again. Not so sure that this whole sprint race thing's a good idea. Kind of a bit worried we're going to have no riders left after a few races. So let me just check this jogging. So if I manually jog just on the controller, no, that's the right direction. And counting up. Okay, so that's all correct. Getting less negative, getting more negative. The encoder's indicating in the right direction. So it must be the commanded direction from LinuxCNC that's somehow reversed. Which makes no sense because I've changed nothing in my settings. And this is the original drive that was working correctly in this location. I've had a bit of a think about it. These are the analog out signals. See how I've got white brown, but up here I've got brown white. When I originally wired that, I think I marked the wires badly, and when I reconnected them and marked them, I figured, well, it's only an analog out signal, it doesn't really matter which way round it is, I can just fix it in software. So that'll be the reason why my y-axis is now going in the wrong direction. Now I could switch the wires and relabel them, but it should be easier just to go into software and just put a minus in front of the direction. Schaublin 125 CNC INI. So somewhere here I should just put a negative. output scale. There we go, output scale -10. So if I change that to an output scale of just 10, go and now start LinuxCNC. Right, that's it. Minus numbers, plus numbers. So that's all there was to it. Let's home it. Good, well that was also easy. So let's look at the spindle encoder. If I turn the spindle by hand, I should see a positive number here for RPM. Turning backwards, I get a negative RPM, so that's good. What happens when I hit the spindle on command? Turning clockwise. Now, I had problems with it before. I've already got an issue, I think, when I go backwards. Yeah. When I command backwards, it still goes forward. I know I've got an issue that I need to address there. So with that, I'm basically now back to where I was before I pulled everything apart. Now so far, I've just been using this backside tool holder, which is really for cut-off tools. But I can't hold any form of boring tool in here, so it needs to move. Just shove that over the back out of the way for now. That's good. Now I'll be able to mount boring tools into collets either here or using this tool holder. In fact, I should even be able to gang two of them into one spot. Probably needs to go down a bit. It's kind of cute. Now how am I going to turn this? Turn the outside feature and the thread, then flip it around. Either hold the thread, which is not a good idea in plastic, or hold the outside diameter, turn away all this, and then trepan the inside. Or it's the other way around. I grab here, turn all of this, trepan the inside, flip it around, grab it by this, turn the outer diameter and the thread. Yeah, that sounds like a better plan. Then I don't have to try and grip onto this weak outer edge. I can always grab onto this shaft. Next issue is, how do I trepan out that center? Luckily I want quite generous radiuses on it, so it doesn't have to be some sort of a sharp tool. But looking in my specials box, don't really think I've got anything that could reach in there and do the job. But I do have this piece of carbide, which was some old dead tool that somebody gave me. Last time I was turning PVC, I found it quite grabby. I'll make a tool with zero top rake and see how that works. Since I need a tool ground, it's lucky I've got a tool grinder. Since I want this tool to be kind of a ball nose tool, I'm going to need my radius grinding attachment on here. I'll bolt it down here. My experience is you have to change everything 10 times before you finally get things set up with this machine. It's not going to need any back relief, so I can drop that down. Being carbide, I'm going to need a diamond wheel on there. It's amazing how handy an angle grinder's cutoff disc is on these sort of machines. I'll just roughly set the stop blocks. For tool holding, got this ER16 collet chuck. Then we use one of these guide bushings. Put the ER collet in there. It's like a locking collar around the outside of it, just so it doesn't fall off, but just spins. And then I can set the radius. Obviously it pivots around that center there. I made up this bar hardened and ground it, so it's the radius of that little setting shaft. So if we run this all the way into the setting bar, and then run the workpiece to there, that means that the tip of the workpiece would be directly on the center of rotation. So to set a specific radius, in this case I want 3mm radius for a 6mm diameter, so I'll take a 3mm Joe block, loosen off the stop, put in my Joe block, run that up and bolt it down. Now once the tool blank touches it, we should be good for a 3mm radius. One of the really fun things about a tool and cutter grinder is that once you've got everything set up, you'll almost always find that you can't reach the wheel. And then you change things. Yep, that looks like it's the case. How do I get that further over? I need to mount the whole thing 180 so it's centered on the other side. Now I need to set those stop blocks again. Once the tip adjustment's done, the next thing is to set the side-to-side adjustment. That's done with this little cross slide. Just loosen that off. And now we can move this over until it's about the same distance away. As I've got a lot of damage to take off this tip, I'm just going to have to make little incremental moves into the wheel until I've cleaned up all of the damage on the tip here. Well, that's now roughed in. I didn't take all of the damage out, but that doesn't matter because the next part I need to do is split the point to about half the diameter. Measures pretty much exactly 6mm. So I'll just grind it away until it's 3mm thick at the cutting tip. I'll turn this damaged part to the wheel and lock the rotation. Then I'll just move the stop around. Stop that rotation, and I just need to feed in and go backwards and forwards across the wheel. Half a millimeter to go. Okay, so I've gone about 3/100ths under half. That's good. You want to be slightly under rather than slightly over, so that it'll cut. So there's the finished tool there. Now, if I was going to cut metal, I have to make sure there's a proper back clearance around the side. Now, because this is only going to be driven into plastic, I'm pretty sure that'll work fine. Now, before I set up the CNC, let's just do a quick check on the manual lathe and see if it will actually cut PVC. Yep, I reckon it's going to work fine. Right, next up I'll set up the stock. This is not really a job that needs a 4-jaw chuck, but I don't have a 3-jaw chuck. Okay, this bar is not round. Right, setting up the tool table. This job's going to involve 4 tools. Starting off with tool number 1, which is just a normal right-hand cutting tool. I'm using an aluminium insert, nice and sharp. Now on the mini lathe, these high positive rake tools tended to pull PVC out of the chuck, but here I've got a much more rigid setup. I'm guessing it should be okay. That's going to be tool number 1. It's a right-hand TCMT cutting tool. Okay, that's what I've already got. The second tool I'm going to use, I'm going to call this tool 50, and it's an knurling tool. So let's add a tool. Tool number pocket 50, a knurl. Apply that. Now I still need to work out the offsets of all these, but first I'll just think through what I'm actually going to use. The third tool I'm going to need is the one I just made. That's going to be tool number 40. A ball nose form tool. Oops, I didn't name the knurl properly. So apply that. And my fourth tool is going to be my threading tool. It's tool number 3. It's already in the tool table, 60-degree insert threading tool. Now all I need to do is set the offsets of each of these. I've touched them off. So let's go for tool number 1. Right, that tool is currently a mile below centre height. That's the centre there, that little spot. So here I am, running through each tool in turn, checking the tools on centre height or adjusting it, touching off on diameter, touching off on the radius. At each touch off, LinuxCNC updates the tool table, so I've got the correct offsets between tools when the program runs. Okay, first stop went okay. My stock was very slightly shorter than it was supposed to be. Okay, that didn't work. Hung up on that knurling tool. Bugger. Okay, let's try that again. I think I'll leave that, move on to the third part. The ball nose tool. Well, as is often the case, the bit I was worried about most, which was breaking this carbide tool, that didn't happen, that worked fine. But something as simple as knurling, I totally screwed up. The little cup sort of feature came out pretty well perfect. Now reverse it in the chuck and dial it back in to turn the other side and do the thread. Okay, I just stopped that because I wasn't sure if I was going to hit the jaws if I keep going back. I'll just switch to the second toolpath now. Well, that's a pretty nice looking thread. How does it fit? Yeah, it seems a little bit too tight, maybe a lot too tight. Just tweak the thread depth and let's run it again. I think the reason my thread depth is so far out is because I thought it was an M14 fine pitch, but it's an M13, or maybe something completely different. Okay, so that's that first part. Well, I think that's going to work. I don't think I'll bother redoing it yet because the second thread below may also break. If that's the case, I could make this whole thing out of one part. But hey, that's going to work. Thanks a lot for watching. Catch you next time.